Hi everyone, and welcome to Get Good at Maths. Yesterday we went through the first paper and we got up to question 5. So we will start on question 6, and here we go.
Number 6, complete the table of values for y equals x squared minus 3x plus 1. And once you've done that, then you need to put it on the grid and draw your graph. So I've just rewritten the equation and I've put brackets in the correct place. And to get the y coordinate for when x equals 2, all you're going to do is substitute 2 where the x would be. So it will be 2 squared minus 3 times 2, which will give you 4 minus 6 plus 1, which will give you minus 1. All quadratic equations have a line of symmetry. So once you've got your line of symmetry between the two bits that have repeated themselves, then everything on the left will be the same on the right. So this coordinate for x equals minus 1 will be the same coordinate for 4. So you don't need to do both of them. So substitute, I would go for 4 rather than the minus 1 because that's a bit easier. So it will be 4 squared minus 3 times 4 plus 1. 4 squared is 16 minus 12 plus 1, which will give you 5. If you wanted to do the minus 1, because there might come a point where you would need to substitute a negative number in, it would go minus 1 squared minus 3 times minus 1. Minus 1 squared is actually positive 1, minus 3 times minus 1, which is going to give you minus 3, plus 1. If you have a negative and negative in a row, this actually means 1 plus 3, and then add the 1, which will give you 5. So either way, it's 5. Then you're going to plot them onto the graph. So it's going to go minus 1 and 5, and 0 and 1. Once you've plotted your parabola, if you've got 2 points in line with each other for the turning point, I would just find the midpoint and then go in between so it's got a nice curved turning point. And you just go down as nice and smoothly as you can. And you should finish like this. Using your graph, find the estimates for the solutions of the equation x squared minus 3x plus 1 equals 0. And what they've done is replaced y with a 0. So you're going to draw the graph y equals 0, which is this line here. It's essentially you find your y-axis and you travel through at 0 there. And where it goes through the x-axis, or y equals 0, are what we call the solutions. Sometimes they're also called the roots, and you've just got to know both of them. So the x coordinate is about 0.5, and the other x coordinate is about 2.5.
Number 7. Here are two cubes, A and B. Cube A has a mass of 81 grams, and cube B has a mass of 128 grams. Work out the density of cube A to the density of cube B. Give your answer in the form A to B, where A and B are integers. And integers just means whole numbers. There is a relationship triangle that we've got to use to work out density. And density essentially is how heavy something is for its size. So we say your density is your mass divided by your volume. And it hasn't given us our volume, so we've got to work it out. I'll split the page and we'll go A and B. Right, we've got to work out our volume. So volume for A, it's a cube of 3 centimeters per side. So it will be 3 to the power of 3, which will give you 27 centimeters cubed. And the volume for B is each side is 4. So it will be 4 cubed, which is 64 centimeters cubed. And your density is your mass divided by your volume. So it would be 81 grams divided by 27 centimeters cubed, which will give you 3 grams per centimeter cubed. And for B, it will be 128 grams divided by 64 centimeters cubed, which will give you 2 grams per centimeter cubed. and the ratio is therefore 3 to 2. Number 8. The table shows the amount of snow in centimetres that fell each day for 30 days. On the left-hand side, you've got our upper bounds and lower bounds, and there was a frequency of 8, 10, 7, and 2, and all the rest of it. What this top row means is it means there were 8 days where it snowed between 0 and 10 centimetres. There were 10 days where it snowed between 10 and 20, and so on. The mean is like the average, and so it's the total amount of snow, and you're going to divide it by the number of days. We don't know how many centimetres of snow it snowed for those 8 days, so what we actually do is we find the midpoint between 0 and 10. So we're going to pretend that it was 5 centimetres of snow every day for 8 days. Then we're going to pretend it was 15 centimetres of snow, and then for this one we're going to pretend it's 25 and 35 and 45 centimetres. I'm now going to work out how much it snowed by multiplying the frequency by the midpoint. So it's going to be 8 times 5 and 10 times 15, 7 times 25, 2 times 35, and 3 times 45. So that's 40, 150, 175, 70, and 135. And if you add them together, that tells you how much it snowed. So that's 10, that's 27, and then, so 570. So the amount of snow is 570 centimetres, and then you're going to divide it by how many days. If it tells you in the question, you'll just use the number. If not, you have to add up all the days together, but it's 30. And I believe that is 19. Number 9. A cube is placed on top of a cuboid, as shown in the diagram, to form a solid. The cube has edges of 4. In fact, should we call this A? And then we can call the other part B. And so there's 4 centimetres for the cube, and the cuboid has dimensions of 7, 6, and 5. Work out the total surface area of the solid. Okay, nice. The only problem with this is this top part, and that can be the one problem. But we'll stick with A for the time being. Now, A has got 5 visible sides, and then it's got this base that we actually can't see because it's in contact with the top of the cuboid. So it's only got 5 faces. So we're going to do 5 lots of, and then each face is going to be 4 times 4. And then that will give you 16. So it would be 5 times 4 squared, which is 5 times 16 for 80 centimetres squared. 80 centimetres squared. We'll box it off so we don't forget to add it on the end, and then we can stick with B now. Right, B is going to have a left side and a right side, which are identical. So it will be 5 times 6, 5 times 6, which is 30. That's one of the sides, and then 30 times 2 will give you 60 centimetres squared, and then that's going to be the left and right combined. Then it needs the front and back, which is this bit and that bit there. So that's going to be 7 times, how tall is it? 5? 7 times 5. 7 times 5 for 30, 35. 35, and then we do 35 times 2, which would give you 70 centimetres squared. So that's the front and back. And then it's just the top that we've got to work out, and the base. So the base is 7 times 6. So 7 times 6 would give you 42 centimetres squared. And it's this top bit. And the whole top is going to be 42 centimetres squared, but we've got to take away one lot of 16, which is the base of the cube there. So it will be 42 minus 16, which will give you 26 centimetres squared, and we'll box him off and the 42 centimetres squared off, and it's just about adding them all up together now. So total is going to give you 80 plus 60 plus 70 plus 42 plus 26. And we just need to add them all up together, which will give you 8. 2 and 8 give you 10. 6 and 4 give you 20. 27. 278 centimeters squared. Number 10. The table shows information about the profit made each day at a cricket club on 100 days. And on 10 days, they made between 0 and 50. 15 days, they made between 50 and £100, and so on. And it says complete the cumulative frequency table below. And what we do is we start at the top, and then we just keep adding every single value as we go. So it starts on the top and 10, and that's because between 0 and 50, see, 0 and 50. And then the next one, it says between 0 and 100. So that's between 0 and 100 here. So you've got to add these two together, and then you'll get 25. And then it's between 0 and 150, so 0 and 150. Add the extra 25, 50, then we add the extra 30, 80, add the extra 5, 85, and 15, add it on for 100. On the grid, draw a cumulative frequency graph for this information. Okay, great. And what you do is for this, you plot your cumulative frequencies against your upper bounds. So don't go thinking it's the midpoint. That's only for frequency polygons. So upper bound against the cumulative frequency. And you've also got to plot 0, 0, or the lower bound of the top one. So 10 and 50 and 25 and 100 for the first one. 10 and 50 and 25 and 100. And then don't forget the important 0, 0, 1 as well. Now you mustn't ever use a ruler for this. It's got to be freehand, and it should look like an S shape when you're finished with it. Part C. Use your graph to estimate the number of days on which the profit was less than £125. So we're going to go up from £125, which is here, and you go up with a ruler and stop. And then you need to go at right angles to the line and stop like this. And anything less than £125 is all of this, and anything more than £125 are all of these days. So it's going to be, there's 30, 32, 34, so it goes through at 34 on the y-axis there. 34 days. Part D, use your graph to estimate the interquartile range. Now the interquartile range is the 75% mark minus the 25% mark. Sometimes we call it Q3 minus Q1, like this. To find your 25% mark, you divide by divide by 4, and there's 100 people in total, so we'll do 100 divided by 4, which will give you the 25th person. So there's 20 and 25 is about here. So you go across like this and down. So that's about 100. So we're going to subtract 100, and your 3/4 mark, you just times by 3 at the end. So times by 3, that will give you your 75th person. So 60, 70, 75 is right here. We go across and down. And then that's going to be 160, 165, 170. So it will be 170 minus 100, which will give you £70 for your interquartile range. Well, there we are, up to question 10. Join me tomorrow and we will go through the next set of questions. I believe there are 21 questions, so we are just under halfway through.